So welcome to video 3, where I'm going to talk about using the BJT as an amplifier. So as the name suggests, it's going to amplify a signal. So this is the configuration of a BJT as an amplifier. So technically, if I put in a signal like this in the input, okay, it goes in. Hopefully what I want is a signal that is amplified, okay, so it gets bigger, amplified. So this is basically what I want. And how do I get this outcome? Well, I arrange the BJT in this configuration. Now you'll be wondering, why this configuration? Like what does all these capacitors, resistors do? You don't need to know that. Just remember, in this configuration is going to amplify your signal. Okay, don't confuse yourself. Just know that signal in, signal out amplifies this configuration. Okay, so I'm going to teach you how to analyze this circuit and to find out how many times it's going to amplify your signal by. Okay, typically these are the values that you need to find out. VB, the base voltage. The base voltage is over here. So what I'm going to do is I'm going to do a simple voltage divider method. All right. So this is very, very basic. You must know how to do a voltage divider calculation. So VB is going to be the resistor here over the total resistance multiplied by the voltage here. So 3.3 over 13.3 multiplied by 9 volts, and this will give me, I'm going to cheat here, I'm just going to check the answer, it's going to be 2.23 volts. Okay, so it's going to be 2.23 volts. All right, so if you are wondering why are they asking us to calculate all these values, I don't know, because they want you to just calculate. I'm going to show you how to calculate. This is the question. Okay, next, calculate VE. So I'm going to show you how I'm going to get VE. Remember, we have VB now, right? So we have got the VB value. I want to calculate the VE value, the voltage at the emitter. So to get from here to here, I need to drop a voltage to get down here. Remember, I keep telling you there is a voltage drop called the VBE. So there's going to drop a voltage to get to my emitter over here. So I've already found my VB. And if I take away that voltage drop called the VBE, I will end up with my VE. Okay, so VB I found to be 2.23 minus my VBE given here as 0.7 volts. I will have my VE. So therefore VE, I'm going to cheat again. If I'm going to take 2.23 minus 0.7, I'm going to have 1.53. I'm going to have 1.53 volts. Okay, next they want me to calculate what is the emitter current. So they want me to find out what is the current flowing down here, the emitter current. Okay, so once again, if you're wondering, why is there a current flowing down here, go back to watch video 2. Okay, it tells you about the currents flowing into and out of the BJT. So I have the voltage here, I have the resistor here. Isn't it just a very simple Ohm's law application to find V equals to IR? Yeah, so I've got the voltage, what was it, 1.53. Okay, I've got the voltage all the way to 0 volts, so I know the voltage across this fella is 1.53, and this will be equals to the emitter current, IE, multiplied by the resistor, which is 1.2K. Okay, so therefore IE is 1.53 divided by 1.2 kilo, and this will be, let me cheat again, This will be 1.28 milliamps. 1.28 milliamps. Okay? So you see that it's just a very natural progression. The way they ask the values that you need to find, it's a natural progression to get from here to down here to down here. So long as you don't miss a step and you use your basic Ohm's law, Kirchhoff voltage law, you will be able to find out step by step the values. Now this next part is where you need to listen carefully. So listen carefully now. I know I've been telling you the emitter current is made up of the collector current plus the base current. Okay? But in this case, when you're analyzing a BJT as an amplifier, you can neglect the base current because it's small. We know it's going to be about 40 to 300 times smaller, so we can kind of neglect this value to make our circuit analysis easier. And we can say, because the next part they want us to find what is the value of the collector current, we can say, because this part is small, we can assume that the collector current is more or less equals to the emitter current. Okay, so we are going to disregard the base current completely. So let me write that down. So we are now at part D. I'm going to say that the collector current is going to be about the same as the emitter current. So we are going to disregard the base current because the base current is negligible. It's about 40 to 300 times smaller. It's negligible. So we are going to assume that this current is going to be the same as this current, which is 1.28 milliamps. Okay, so this is part D. All right. Part E, they want us to find VC, the voltage here, the voltage at the collector, VC. Okay, so to find VC, this is part E, I'm going to use Ohm's law over here. So I have 9 volts over here, right? 9 volts. I'm going to drop some voltage. I'm going to drop some voltage and I'll end up with the remaining voltage here called the VC. So voltage 9 volts. So VC, I'm going to start with 9 volts. 9 volts. I'm going to drop some voltage over here. Take away some voltage drop here. And the voltage drop is V equals to IR, Ohm's law here. I, we found to be 1.28 milliamps. R is 3.3 kilo. So the milli and the kilo is going to cancel out. I'm going to cheat again. VC is 4.78 volts. So this is 4.78 volts. Okay, so I found out what VC is, 4.78 volts. Now they want me to find for part F, the value of VCE. Okay, VCE, you know, if you remember that VCE is the voltage drop between the VC and VE. Usually, previously, it has been given to you, but now they want me to calculate it. Okay, so to calculate VCE, I take VC minus VE. The voltage here, take away the voltage here, I will end up with the voltage drop. How much was used to cross from VC to VE? So VC we calculated earlier to be 4.78. Take away VE, which we calculated earlier. Where's my VE? My VE is... Where is my VE? 1.53 over here, sorry. 1.53. Going to check the answer, which will be 3.25. Okay, this will give me 3.25 volts. All right, so another thing that they want you to calculate is this this little thing called the gain. All right, so how many times will they multiply the input to give you the output? So to calculate this value, you need to take RC. So AV is actually So remember this. This one you have to remember. I haven't taught you anything about this. RC over RE. So you have to remember this formula. Okay, RC equals to over RE. So RC is 3.3 kilo ohm, and RE is 1.2 kilo ohms. Press your calculator, you'll end up with 2.75 times. So you know that whatever input I give here, the output will be 2.7 times bigger. All right, and why do we have the absolute sign here? Now technically the output will be 180 degrees out of phase. Okay, technically I will not land up with this. Technically, if you use the oscilloscope, I will end up with a signal that looks like this. Okay, it is 180 degrees out of phase, but doesn't matter. Some of you will be going, whoa, why? How did this happen? Does not matter. All you need to know is that this is the reality, and to make sure that we are not confused by the out of phase part, what we do is that we put an absolute sign, and we just want to tell the people that this configuration will increase the gain, will get the signal gain to be 2.75 times bigger than the input. Okay. Now, if you don't have the absolute sign, what you can do is you can actually put a negative 2.75. That's fine. Okay. So if you have the absolute sign, that will be positive 2.75. If you don't have the absolute sign, you actually have a negative 2.75. Okay. So the last thing that I do want to talk about is the two capacitors there. Where? Over here. So the two capacitors here, C1 and C2. C1 and C2 are called coupling capacitors. All you have to know is that they allow AC to flow in and stop DC. That's all you need to know. It allows AC, but it stops DC for both of them. Okay, just remember that and you are fine. That's it. Okay, and there's one more capacitor somewhere over here. So one more capacitor called C3. Now this is called a bypass capacitor. What it does is that it allows you to increase the voltage gain. Remember the AV that we were talking about, the voltage gain? By adding this fella, you're going to increase it somewhat slightly. Okay, so that's all you need to know. If you're asking me, how does that work? Why does it do that? Doesn't matter. You don't need to know. Just know that by adding this, it increases the voltage gain. Now, I want you to go and try out the review question 9.4 on page 247. Okay, go and try out this review question. I've already included in the answers for you to check. So pause the video here, do this, and check your answers here. All right? And the next time that we meet in the video, I'm going to teach you how to identify different parts of a current voltage graph of a BJT. Okay, so do this, and I'll see you next video.